electricity as one of those familiar, everyday facts of life, and yet it confuses pupils and teachers alike. What is it about electricity that people find so baffling? This is what Key Stage 3 pupils think.
Does all the electricity turn into heat and light?
Some can be wasted.
Some can be?
Because some energy can be wasted when you use it.
Where would that energy go?
It would just be used up.
If children are trying to learn about electric circuits, we're asking them to imagine things that they can't see and that they've got to get their heads around.
If you take it out, the energy just vanishes into the air, I think.
I think electricity is such a difficult topic in the classroom because it's very abstract. It's difficult for students to see what actually teachers are talking about.
So you think there's chemical energy going around here? The children have some very strange ideas about electricity. They are trying to often find out what you want them to think. So what's in the battery?
Gas.
I think that any effective teaching really must start with where the kids are up to at that point. So if we're involved in teaching something like electrical circuits, it's important for the teacher to be able to identify what the children's existing understandings are, so then the teaching can move on from there.
Why do we need the wires, Catherine?
Because if we didn't have the wires, the circuit wouldn't work, so it wouldn't light up.
There are three basic misconceptions that are possible. One, that you just require the one lead in the electric circuit, so it's just a one-way action. The second, that you need two leads, and there is a clashing current action. And the third one is the consumption model, that something's getting used up, and in that case it's the electric current.
Well, thank you for your answers so far. There's some very interesting answers.
Having established the children's existing understanding of electrical circuits, head teacher Brian Crosby sets about teaching the accepted model of how electricity works.
This is the...
That's the bulb.
That's the bulb.
The next step is vital. It's crucial to address the issue of how the circuit works.
One of the challenges that children face in developing a real understanding of electric circuits is getting over the notion that the action doesn't all start in the battery. If you ask youngsters how an electric circuit works, they say that something comes out of the battery and makes the bulb light. With that model in mind, it's quite interesting to face the children with a challenge. And the challenge that I've used lots of times in the past is to set up a big circuit in the laboratory.
I've got another circuit over here.
The big circuit is a basic battery and bulb setup, but with much longer wires.
The wires attached go all around the laboratory. Can you see them going all the way around? And they come to the bulb at the back. Now, what's the difference this time, do you think? Yes.
The energy's got a longer way to travel.
It's got a longer distance to travel. If I touch this now, how quickly does the light come on?
Quick.
Yeah? Now, who can tell me, if I touch on this one, it's going to be more difficult for us to see. What do we think is going to happen this time?
If the youngster believes that everything starts at the battery, then they will predict, as is usually the case, that there will be a slight delay before the bulb lights in the big circuit.
And how long do you think before the light bulb comes on, do you think?
I think it'll take a couple more seconds than that one.
You think this time it's going to take a few more seconds. OK, well, we're going to find out. 3, 2, 1. Let's do it again, just to test it out. 3, 2, 1.
Yeah.
What did you notice?
It took the same amount of speed to light up.
It took the same amount of speed to light up. And I'd say we've got about 30 metres of cable here. So we have 30 metres of cable, and it still took the same time to light up.
When the experiment is actually tried out, you see that the bulb lights immediately, no matter how big the circuit is. And so here we have to move towards the idea that when the circuit is complete, then the action starts in all parts of the circuit, right from the word go.
Did that surprise anybody? How many people were surprised by that? OK, how many people expected that to take place? Well done. So the electricity travels extremely quickly.
I particularly like the big circuit idea because it really does engage children intellectually, and to actually hit the switch and to see the bulb light immediately, and to have children in the room crying out, oh no, it's lit straight away.
If young people make the discovery themselves, it means more to them because it's their learning and they have ownership on that and they feel really proud of what they've done. What we're trying to do is, in one sense, put the outside of the jigsaw puzzle together for the young people so that they can fit the other pieces in place themselves. Some people think that the electricity just leaves here and kind of runs around, then runs back. Does that make sense? Yeah? But actually, all the objects that are going to pass the electrical energy are already in the circuit. Okay? They're already in the circuit. It's not like there's a little object in here that runs all the way around and comes back. They're already in there. And to demonstrate this, I've got a rope.
The rope experiment is a really simple and effective way in the classroom to counter a lot of pupils' alternative conceptions and get them starting to think about what's actually occurring in the full circuit. It's very simple, it's very interactive, and it's very easy to use.
Now, imagine you are a circuit, and I want you to imagine that I am a battery.
The rope trick is a great way to demonstrate the continuous nature of the circuit and that charges exist in every part of it.
Now, I want it to be fairly tight, but I want you to hold your hand so that I can pull it through. Is that okay? Have you got it?
It's advisable to have something that you can see that moves on the rope, so tying a piece of ribbon or a bit of tape so that the pupils can actually see the rope is moving. So as the teacher pulls the rope through, they can show that the whole of the rope starts to move at the same time.
In which ways is it similar to what we've been talking about?
Because she said that there's loads of little bits already in it and everyone's holding a bit already.
So we've got something already. And it's also complete. If I'm the battery, let's see what I'm doing here. What am I doing?
You're pulling it through so it's circulating, and if you imagine that was the electricity, it's going through each bit of wire, and then that goes through, and then the next bit comes through and it keeps circulating.
What's the job of the battery, do you think? Josh?
To get the energy round the whole way round, the circuit.
That's my job, it's going around, okay? Is there any less in any part of the circuit? Mr. Reid?
When it comes back to you.
Is there any less rope? Who's doing all the hard work in this model? Yeah?
You are. And the battery.
The battery's doing the hard work, okay? So the battery's providing the energy to make this thing work.
It's a really good analogy for showing how the battery works because the teacher can pull the rope at different rates, which shows how fast or how slowly the battery forces the current to go around the circuit. And one last thing the teacher could do, picking on a pupil that you like, is you could ask them to hold the rope slightly tighter, and what will happen is as you pull it through, with it being a rope, you get a lot of friction, so you can talk about, well, a lot of energy has been transferred at the point where resistance increased.
OK, now I want Catherine to hold the rope tight. If I pull, I should be able to pull it through. It's harder this time. Would you agree?
Yeah.
Catherine, what does your hands feel like?
They're getting really hot.
They're getting really...
Hot.
Thank you, they're getting really hot. Which part of the circuit is Catherine like then?
The light bulb.
The light bulb.
The rope loop idea came from some work we were doing at the University of Leeds. People thinking hard about how to challenge pupils' existing ideas and how to have a memorable image of things moving in all parts of the circuit all at the same time.
What I was trying to think about, it was bringing in the concept of where energy is in an electric circuit and starting to get pupils to actually visualise this thing that's occurring with energy. And what I wanted to show was how energy that's in the cell, the battery, is used to move the charges to different levels of potential.
Now this is a model garage. The cars I want you to think about are like the charge that's going around an electrical circuit. And this is a bit like a battery. Okay? It works like this. When the car comes in here, I can lift it up. Car goes off here, and I can take it around here, and then suddenly it can go back down. Why is the car able to go down the slope from here and not move when it's on the desk there?
When it's at the top of the vamp, it's got gravitational energy, and when it goes down, it uses up the gravitational energy.
It doesn't use it up, it changes it into another type. What type does it change it into?
Kinetic.
Kinetic, that's brilliant, that's a fantastic answer. It changes it into kinetic energy.
I like to take learning back to a visual level. when they're starting off with difficult concepts. I was trying to visualise something that showed an object going from one level to another.
Fantastic. This is a piece of equipment to enable the car to gain gravitational potential energy, yeah, so that it can change into movement. Now the battery is a piece of equipment that will provide the energy for this to work, okay? So the particles that flow around in this circuit, they get their energy from where?
You putting on the circuit, fixing up the circuit in the first place.
No, they don't get their energy from me fixing up the circuit. There's just one place they're getting their energy from.
Is it the battery?
They're getting it from the battery, okay? Now, the battery is the provider of the energy. Where does the energy go to in the end?
The bulb.
It goes to the bulb, where it's going to be transferred into
Light and heat energy.
light and heat energy.
The toy garage is an excellent visual demonstration, but it should be used with caution.
The misconception that you could get from that model is that the electrons in the circuit are like little cars that are just travelling around on a pathway. So you've got to be very clear which concept you're trying to get forward.
There are limitations with this model. I was thinking about this. I think one of them is that it appears that the charges just come from within the battery itself, the cell itself, where actually they're out in the wire all there throughout the whole of the circuit. To me, I think that's one of the key ones that I would be aware of at this stage for the pupils. I think a really good way of testing pupils' understanding of these models and analogies would be to get them to work in groups. They could write a story of a charge as it goes around a circuit and explain what they think is happening at different points.
The battery has chemical energy stored in it. It releases the energy, allowing it to flow
through the wires and then transfers into light and heat. And the remainder travels back to the battery. What else?
Can you tell me, is that right, wrong? What would you think about that idea now from what we've learned today?
No, that's wrong because we learned that
comes from the negative side.
Yeah, we've learned that it comes from negative side and then comes back in through the positive.
So it doesn't come out of both ends?
No.
It comes back into the bulb?
No, because where would the energy go when it's just gone from both ends? It has nowhere to go besides lighting up the bulb.
Ah, okay, so it wouldn't. Okay. So I need there to be the complete pathway, the complete circuit for it to work.
Yeah.
By using these demonstrations, teachers should be able to provide children with a solid understanding of basic electricity.
We want, by the end of the lesson, to have unpicked the wrong ideas, to give them some simple basic concepts, and we want to give them a framework for their own learning for the future.
I think that at the end of Key Stage 3, if children had a strong idea that a circuit involved charges circulating around the circuit in a continuous loop with energy being transferred from battery to bulb, if children had that as a robust understanding, I'd be very happy with that.